Good morning, everybody. My name is Steve Schrock. I work for WP Carey. I'm a business systems analyst and AWS CSA, or Solutions Architect. So essentially, I help architect, migrate, and develop systems and applications for WP Carey via the AWS or Amazon Web Services cloud platform. And we're here really to talk about the cloud, very generally what that is, and a bit more specifics on Amazon Web Services, how we use it, what the architecture allows you to do, and really how awesome the cloud is and the capabilities and unique value that it can create for businesses or for IT implementations in general. Now, just to start off here for a couple things, I'm going to be doing some annotation, and everybody should be aware that the limitations of my drawing capability are about this and this. So, don't expect much more than that. So here we have a computer, and here is a person. So, yeah, we'll do the best we can with what we've got available. But I think we can tease out some really interesting understanding of what the cloud can afford you and your future jobs and businesses in general to do. Let's start off with, what is AWS? AWS, or Amazon Web Services, is a cloud computing provider for currently about 47% of the public cloud. The public cloud being cloud resources or cloud computing that businesses or individuals can use to build things and host computers or applications or servers or sites, things like that. They have a huge international fault-tolerant, redundant infrastructure that essentially amounts in some ways to a very large compute cluster, and we'll go into that in a great more detail here, but let's start with some principles and establish some common terms and language understanding for what cloud computing really is. So I don't know if any of you have ever used any of the websites, pretty common ones. Netflix, anybody ever heard of that? Yeah. Uber, Airbnb, maybe. Instagram, NASA, JPL, the NSA even. Those are all applications or platforms or sites that are hosted on the cloud, or specifically on Amazon Web Services. Undoubtedly, most of you have heard about the cloud. Is it this? Are we talking about a cloud? Are we talking about putting data up ethereally somewhere in the sky? Not necessarily. No, that is not really the cloud. That's not really what we're talking about. Essentially, what it means for something to be in the cloud or to be cloud hosted is that it is on someone else's computer. You have your computer, and in traditional architecture there would be servers, and essentially the cloud is just hosting things that would be normally hosted on a server in a data center on a bigger data center that is owned by a large corporation and that is very redundant. And we're going to go into some of the key differences between a traditional sort of server architecture and what differentiates that from the cloud. So cloud computing really is the ability to use or access resources for your company or organization via the internet or a private connection like a VPN or a virtual private network on a virtualized layer of a cloud provider's physical infrastructure to create secure, and that's a common point of anxiety and contention when we talk about the cloud, especially as it's evolved in the past couple decades, to create durable, horizontal, and vertically scalable, which we'll get into what that means, elastic, and very cost-effective solutions to IT problems that used to be handled on-premise. Now that's a heck of a definition, and I know that this is a 100 course, or at least this was content was originally designed for 100 cores, so that's a lot of things that we need to cover. So let's draw some terrible illustrations here and see if we can make things a little bit clearer. So where do we come from? So really basically, we need to at least have an understanding of what is a data center. So does everyone, kind of know what a data center? A data center is a big building. So here's a building. We're going to say this is a building. It's a two-dimensional building, apparently. And this building has its own very strong power lines coming to it and lots of cooling. Got lots of air conditioners on top of it and whatnot. And it has racks and racks of servers inside of it. And I don't know if does everybody know what a server is? So here's a traditional data center at, like your business or in a school or something like that. We have servers, we have storage clusters, we have networks, we have patch panels here, we've got that patch things into routers and switches and send information all through your organization. Maybe we have a SAN, things like that. So this is a traditional architecture. So you would have this room in your business and have it cooled and have it powered, and you would have a server or 2 servers or 3 servers or 4 servers, and they would all serve different applications. This one serves your SQL, this one is your web host, this one hosts your Active Directory infrastructure, something like that. And all of these maybe they're redundant in that they have RAID arrays, which is a method of retaining or improving performance across multiple drives, striping data across multiple hard drives. These are hard drives with data striped across them. And this is all well and good. This is how the entire architecture of the internet or hosted sites and applications has existed for decades. But now we have something, and in the past little while here, we've transferred more to what are called data centers. This being a visual demonstration of a data center. Data center is just more servers and infrastructure and networking and storage clusters and cooling and lots of power. And data centers are usually very physically secure in that they have, they're in buildings that are isolated from access and very controlled. They have guards sometimes. They have all kinds of things to keep people from getting in and out of them. And data is striped across. You can either rent server space in here, so you could use this for your web applications. You access it remotely via the internet, or you can that would be dedicated storage or server usage inside of a data center. But the cloud, as we think of it today, really involves multiple data centers, so many data centers of this kind of nature, and then using virtualized layers on top of all these servers and striping data across them and making it so that things are so redundant and so resistant to data loss or failure and even security that it really creates a unique value. So again, what is a data center? Well, a data center is a large compute cluster of servers or data storage nodes or networking that businesses can connect to for various purposes. Most everything you use on the internet is probably realistically hosted on a server in a data center somewhere at this point. As opposed to these more on-premise, old-school style sort of servers, or just basic little server rooms or individual servers. So let's do a little use case here to compare why we might want this as opposed to this. Aside from the idea of security. So traditionally, if we want to spin up a website, we want to make a website, and it's called Steve's Terrible Drawings. Steve's Terrible Drawings, and we've got one of my drawings, and this is going to be a huge website. We think we're going to make a lot of money off this website because my drawings are great, and we're going to need to build. In traditional architecture, we're going to need to go to our CEO and say, "Hi, CEO, I need X amount of money to build our new server, to build our servers here and our routers, and to hire people to put all these things together, and we need to develop our website, and we need to build these servers to have enough capacity that if we get 10 hits on our website, or we get 1,000,000 hits on our website, we need to be able to, if this is our usage graph here, if we get 10 hits and then all of a sudden we go up to 1,000,000 hits, we need to build our capacity on that server, on our on-premise server here, to be able to handle that. So we need to build our server this big so that our projected capacity never exceeds that. So we need lots of money to do that, and we need it up front, and we have to project, using the best estimates that we can, how much usage we're going to have at the very top of our website's popularity or application or whatever you want to host. And that's a very difficult thing to do, and it takes time and money and people and cooling and power and all kinds of resources, most notably time, to build this infrastructure and implement it and deploy everything to it. Now, the difference between that, and this is extremely key, with the cloud, is that we can, instead of worrying about that upfront capital, worrying about deploying resources and getting people to deploy resources and building all of this nonsense to make our application or our website work, we can essentially build our application. So we can have our developer team make our website, and with the cloud, by deploying to the cloud with resources available, we can take this website and put it on servers, and these servers are connected to other data centers all around the world. So each of these is a data center here with thousands more servers than is in this one, and our website can be replicated across all these data centers almost instantaneously all over the world, and our data is extremely secure, and our data is extremely available. So if I have a computer here, here's my laptop. Yes, let's check out that laptop. That's good drawing of a laptop. If I have a laptop in Tokyo and one over here in the United States, I can have my website deployed here in Tokyo and here in the United States and here in Europe, and all at the same time people can be accessing this website, and it doesn't matter essentially how many hits simultaneously hit my website. It doesn't matter what the original provision capacity is. If we just use one server initially, and to say that we're using a physical server, like an actual physical one of these boxes, is a bit misleading. We'll get more to that in a minute. But as load increases in the cloud, on a cloud host, if load increases, so we have more hits coming in, it says you can do what's called auto-scaling or scaling in general, and it will just provision more servers and host your website on as many servers or as many resources as is needed to provide the adequate bandwidth to reach all of the people that want to reach your website. That is essentially the great benefit of the cloud, is that it can do, and this is the next key point that we're going to, it's extremely durable, which means it's very, your data is very unlikely to be lost. It's very scalable, and it's very elastic, which are terms we're gonna cover here. So, but before we do that, we need to kind of go back a little bit, and we need to look at the idea of virtualization. So, in our long definition above, I mentioned that cloud computing is essentially virtualized resources on cloud physical infrastructure. So that data center that we saw, we have those racks and racks of servers, right? So here's another box, and we have our racks and racks of servers in our data center. And virtualization is the concept that involves adding a layer of abstraction between a physical system, so these physical servers here, which all have, these servers have CPUs, and they have hard drives, and they have RAM, and all the normal things that a computer has. But virtualization is taking and adding a level of abstraction between that physical system and the applications or the operating system or the storage blocks or objects or other hosted data that reside on them. What does that mean? It means the cloud that is essentially, if you still go down far enough, a huge series of servers with physical drives, but that the capabilities of virtualization, which has been around for a long time, I should add, this is not a new thing, it allows many different people to use the same resources or reuse resources securely and in an isolated manner through a virtualization layer. So although virtualization isn't unique to cloud computing, it is hardware virtualization in particular is extremely critical to make cloud computing a reality. Before cloud computers or cloud providers, like Amazon Web Services or Azure or Google Cloud Platform started to come around in the early 2000s, we had companies like VMware, Windows Hypervisor, and arguably even some aspects of mainframe computers that would allow for virtualization or resource sharing. It's really the concept and architectural framework that allows cloud computing to function. So on a traditional computer, like your computer that you're using right now, you have your physical computer, and it has a CPU in it. Here's a CPU with all its little connections out, and it has RAM, random access memory, right? And it has a hard drive. This is not adequate or an appropriate drive. Storage, and it has processing power, and it has all these physical components. Your operating system and software sit on your hard drive and are processed through your CPU and are temporarily stored in RAM as you or your application request them, and that's kind of, extremely high level, like a sort of a 5-year-old sort of level, how a computer works. Virtualization works essentially the same way, except that they add something called a hypervisor, or like something like VMware Sphere or something like that, in between the physical hard drives and the CPUs and RAM. And I assure you, all those data centers have tons of storage and tons of CPUs, and like hundreds of thousands of CPUs or more per data center. And those are divided up in the virtualization layer to different users. So if I have, if I am an Amazon Web Services user, I get provisioned a little bit of the Amazon Web Services data center, and I have the ability to use CPUs and RAM. This is RAM because it's longer, and memory storage, and this is simplifying it a lot, but then I can use these physical resources that are provisioned out and secure from other people using physical resources, and then I can use those to create my OS, my operating systems, or my servers, or my applications, or all kinds of things. And those are all independent of each other, even though they are physically, if you go down far enough, on the same box in the same data center. So that's very generally the idea of virtualization and the sort of fundamental nature of how the cloud works, what the cloud is. It's someone else's computer that you are cordoning off pieces of and isolating to use to build your own applications or servers. So next, let's go here a little bit into the ideas of we're going to get to why is the cloud better, but let's talk about scalability, elasticity, and durability here a little bit. So scalability, as the name suggests, is the capability for you to scale resources to meet demand, just like we were talking about. So again, if we have our usage graph here, and let's say that this is time and this is cost, and our line here is demand. So we are projecting that our demand is going to go up, sort of, we'll say fairly consistently here. We're not going to assume any huge spikes. So in a traditional architecture, you would have to, at first you would build a server. And so here's your first server, and this costs quite a bit of money to build, like we talked about earlier, all the cooling and the power and the people to build it and the infrastructure and buying the servers and getting the servers delivered and getting the servers installed. And then, 6 months down the road, 6 months, our demand here has exceeded our original level of infrastructure that we built. So we have to go back to our CEO and we have to say, oh, I need more money. I need to build bigger servers. So we build a bigger server or more servers. And, 6 months down the road, we exceed that again. And this continues kind of ad nauseum. And at some point, maybe our demand levels off or drops off. And now we have all this compute usage or this compute capacity that has cost us a great deal of money, and we have to maintain, and it ages. So this is getting older and getting less responsive, and we have to repair it, and our usage maybe is dropping off. So we have a lot of invested capital up here in all kinds of different manner. So that's kind of how things have always just been done. Now, the unique thing about the cloud then, or scalability, so scalability and elasticity really is what we're talking about here, is the ability to scale resources to meet demand. So as our demand goes up, so we've got our demand curve, with the cloud, you start off here, and you can always keep, because we can provision almost instantaneously across the world, completely redundantly, we can provision new servers and new storage and new capacity to meet our demand. So even if our demand curve, this is a very linear demand curve, I guess that's probably not actually very realistic. Let's do a bit more realistic demand curve here. So if we're building Steve's new website for Terrible Drawings, and it becomes very popular. It goes viral, and so initially no one's looking at it, and then all of a sudden I have a big uptick in usage, and then it's not very popular again. Now, if we were to provision a traditional architecture for that, we would have built a small server, and then we would have said, oh no, our usage is exceeding, and we would have built a huge server, and it would cost a lot of money, and then it drops off, and we're spending lots of extra money here that we don't need, and we're not using it. So that would be the traditional architecture. With the cloud, we can spin up very small servers initially to stay right where our demand is. And then as we reach this point, and we can create metrics and create alarms and auto-scaling groups and all kinds of things, that when we see an uptick in requests and need for capacity, our servers will scale automatically. It will provision new hardware, provision either horizontally, means it'll provision more servers and replicate them across it. So it'll make copies of the server in the cloud and load balance between these, or we can also scale what is called vertically, which would be the equivalent of, let's say we start off with and by little server I mean, one CPU and, whatever, 8 gigs of RAM, etc. We can also scale vertically, which means we build a larger server. So now we have 20 CPUs, and we have 100 gigs of RAM, and etc. And 1,000. Well, let's say 5 terabytes of storage, and so that would be vertical scaling versus horizontal scaling, which is we just make copies of smaller servers and replicate our load across them. But either way, the key point is that our ability to scale with need is very, very, very elastic. And by elastic, we don't just mean we can scale up with our demand, but we can also, once our demand drops off, we can kill these servers or make our servers smaller again. So if we have all these servers up running our website, right? We've got our Steve's Terrible Drawing website here, and it's running on tons of servers at our peak load because it's very popular and everyone wants to see it. And then at a certain point, everyone gets bored with it and says, "Oh, this website's terrible," which is true. Instead of just maintaining all these servers, which cost a lot of money still, even in the cloud, as our demand dips, we can start deleting these servers very, very easily. And if we are not using them, if we delete them, we're not paying for them anymore. So we go back down from, however many servers, X number of servers, to one server running our website for the people that still like it down here. So it costs, instead of a lot of money, it costs just a little bit again. And so that is the idea of elasticity, that resources, storage, compute, servers, anything can be elastic and change with your demand to meet your demand. Durability. So durability is the last sort of really key concept, which should be, I suppose, sort of evident from its name. It is durable. Durability is the fault tolerance and how resistant that data is to corruption or error. We'll look at this a little bit more in a minute as we talk more about how cloud providers are actually set up in terms of their data centers and things. But for the moment, let's think of as a description of how safe your data is or how many times it's redundantly backed up. In your data center, at your place of work or on your computer, maybe you have a few drives. So in your computer, maybe you have 2 hard drives, right? Maybe. Or you have Dropbox, which actually is hosted on AWS, if you didn't know that. And your data is, there's copies of your data here on this hard drive and copies of your data in Dropbox or on another hard drive. Now, Dropbox is extremely durable because it's hosted on AWS, and we can get to that in a minute. But if this is just another hard drive on your computer, inside your computer, and your computer burns or gets smashed or stolen or what have you, or even if this is on a server and the same thing happens, your data is gone. It is lost. So over the years, people have always done things about, with offsite backup or making copies of copies of copies, and that is good practice. But the nice thing about the cloud is that data is unbelievably durable because of the architecture of the cloud. So Amazon Web Services S3 service, which stands for S3, which stands for Simple Storage Service, which you can store files on, object storage, is striped across thousands of drives and thousands of servers inside many, many data centers. So S3, for example, has what is referred to as 11 nines of durability. Now, what does that mean? Well, that means it's that a file stored in Amazon S3 is 99.9999999 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 nines. It's 99.9999999% probable that your data will not corrupt or lose any of your files. So essentially, what that means is that you would hypothetically lose, because of data corruption or loss. This doesn't count, user error, doesn't count you deleting things, but you would hypothetically lose one file out of every 10,000 files that you have stored on S3 every 10 million years, which is pretty good. I mean, can you replicate that with your own storage cluster on your computer or at your business? I don't think so. Maybe you could, but it would cost a lot of money. And S3 costs about 10 cents per gigabyte, I believe. If I might be wrong about that, but I'm fairly sure it's extremely cheap. And again, you only pay for what you use. If you take your data out, you're not paying for it anymore. If you put your data in, you pay for what you use. It's a different cost model. There's not so much upfront expenditure. So that is durability, and why the cloud offers really unique value in that regard, in that it's so redundant and so over built and provisioned compared to what you could do, that it's almost impossibly durable. So the way that they accomplish that durability and scalability and elasticity varies between a cloud provider. But for Amazon Web Services, for example, they have 44 availability zones, which so let's go here. So they have 16 regions around the world. So these are region and region. They have 16 of these. 16 regions around the world, all over. These are physically isolated. They have their own power. They have their own cooling. They have, they are entirely separate, except they are connected by AWS's private fiber lines. They even have fiber lines that go underneath the ocean that are their own. They are not the primary internet ones or Google's or anybody else's. They are their own AWS network. And inside each of these regions, there are what are called availability zones. Now, each of these availability zones, some regions have 4 or 5 availability zones. Some have 2, I think. They may all have 3. I'm can't quite remember, but they all have availability zones, and inside each of these availability zones are multiple data centers. So you remember that huge server room we saw at the beginning with thousands and thousands and thousands of computers and thousands of terabytes of petabytes of storage. There's multiple data centers in each of those availability zones, and multiple availability zones in each region, and multiple regions around the world. So that is how they achieve the durability and the scalability and the instant capacity to go global, is that your data, when you work in the cloud, is, or can be, depending on how you architect it, and you have a lot of control there, striped across these availability zones, or even across these regions if you want it to be. So that essentially is what makes the cloud unique from having just a data center or just a server, your own server at your house or your computer, right? Steve's awesome drawings here again. So your computer has multiple drives, or this server has even more drives, or your data center has lots of servers. But these are all very vulnerable still to theft or physical issues or power or drive loss or all kinds of things. But when you go to the cloud, you have this capacity, this unbelievable capacity to have durability, elasticity, and scalability across the world instantly, which is really, really unique. So no, we don't need to delete that. Let's move on here. So who offers cloud computing? Now, right now, there's thousands of companies, and there have been thousands of companies, and there's a lot of different things you can read out there about the security of that and the reliability of it. And there's a lot of questions that people ask with validity about is my data secure? Is my data my own if it's on the cloud? Is my data, can we trust these corporations to have our data and things of that nature? Now, some of the big providers, the big 5, I would argue right now as measured by market share, are Microsoft Azure, Amazon Web Services, AWS, which is what we've been talking about, Google Cloud Platform, Oracle, the Oracle Cloud, and IBM, and their IBM Bluemix. Bluemix is what they call it, or Watson, which you may have heard of Watson on Jeopardy. The Watson supercomputer was the one that beat Ken Jennings, who's this Jeopardy super guy. You can look it up. Look up Watson, Ken Jennings, and it's really amazing implementation a couple years ago of AI, and they've continued to develop that. And all of these big cloud providers provide infrastructure as a service, which is what we've been talking about mostly, platform as a service, storage as a service. They're all developing AI now, all kinds of capabilities, and they all, to some degree, have a very similar architecture to what we talked about with Amazon. Now, Amazon tends to be more secretive. They have way more guards and way more security. Now, I'm sure a Microsoft guy would argue with this, but Amazon Web Services engineers never even see Amazon data centers. You can, if you search for Google Cloud Platform data center tour, you can see a tour of a Google Cloud Platform data center on YouTube. They do that. AWS and IBM and Microsoft, to my knowledge, don't really make it quite that publicly available where their things are, and there's lots of redundancy for physical security and logical security. Like your data, now you can make some decisions on this. They have a dual what do they call it? It's a dual responsibility security model, where you're partially responsible for your security, and that you have to make your servers properly hardened and things when you build things on their infrastructure. But on the back end, on the physical end of things, being the location or the actual server hardware, that's all on them, and everything is incredibly isolated, and it's all proprietary built and very, very, very secure. And your data can be encrypted very heavily on all of these platforms, so that even the providers themselves don't know what necessarily you're hosting, which that opens up some regulatory and compliance issues and things like that, which there's a lot of documentation on. But a lot of the security concerns about the cloud, although they are valid. If it's on the internet, it can be hacked, right? Hypothetically, but really, in comparison with the security that you could create for your own data center, these guys, they all dedicate so much time and energy to this that it's impossible to replicate, or seems almost impossible to replicate in your own infrastructure. So yeah, people still fear the cloud. They fear transition to the cloud, but it's really a different animal than it was even 10 years ago. You can build hybrid environments where part of your capacity or your capability to create servers and applications are on your own hardware still, and you can replicate to the cloud. People do that a lot, where they use the cloud as, they start off as using the cloud as a backup location, and they still have their data center on-premise data center, and they have their servers, and they just use AWS or Google Cloud or whatever as they use S3 or something called Glacier, which is cold storage, as a backup location. So they replicate their data up here, so in case this gets smashed by a hurricane or whatever, they have their data and they can pull their data back. Then there are other more direct hybrid environments where people build servers on EC2. Elastic Compute Cloud is what EC2 on AWS is, and they'll build a copy of their server up here, and they'll load balance some of their web traffic to the Amazon Web Services server and some of it to their on-prem server. And so there's lots of different ways that you can architect and build things on Amazon Web Services or any cloud provider. And that's really what people seem to be doing right now, and there's a lot of movement toward that. So I guess we've kind of answered the question of what is cloud computing and how does it sort of very generally at kind of a 10,000 foot level work. I guess to say a little bit more about why cloud computing, it's a ubiquitous quote at this point, but there's you guys may have been told this in your class already, a very common quote about 90% of data, 90% of the data in human history has been created in the last 2 years. So, the amount, the velocity and variety and variance of data and volume of data, most specifically, is so staggering now, coming from Internet of Things devices. Every device that you have has an IP and sends some kind of information back to the internet or to the computer or the server or the host that originally sold you that device. Your watches, your phones, your washing machines, your internet-connected Alexas and Google homes, and your thermostats and everything. And these are all creating digital data streams that are just sending information back to these providers, and just in extraordinary quantities of data. And that's not something that can be realistically or efficiently handled or even assessed or made any sense of by traditional architecture and traditional size limitations of what we used to be able to build. So that's yet another reason that even for small or medium-sized businesses, or even and especially large businesses, cloud computing really is the answer to that. Big data analytics is the answer to that, because of just the capacity that they have to ingest that amount of data and to process or run analytics on that amount of data. So the cloud then provides the incredible ability to store, transfer, process, and build computing infrastructure and capability at an instantly global scale, elastically, so it can scale up and down in ways that we haven't previously even imagined. Cloud computing allows you to create resources that grow and diminish and have very low upfront capital expenditure. So you pay for what you use, that are more secure, more durable, more available. They have, like Amazon provides you 99.99% uptime guaranteed, which means you're almost never down. I don't know if you can do that with your own data center. I suppose you can if you have redundant power and all kinds of things. And very importantly, all these big providers also have regulatory compliance. So they all meet very strict regulatory compliance with a whole host of different organizations that enforce that sort of thing. So you can prove to your regulatory agencies that you are meeting requirements. So a lot of the things that were originally, when the cloud was new, were issues have really been addressed in a variety of ways. So that, I suppose, in a nutshell, is an answer to a lot of questions about cloud computing and why cloud computing. Then, so that brings us back to what we do here at WP Carey. We have started, as I was talking about, to move backups and stored data to the AWS cloud. We host sites for students, for research servers, backups, web applications, servers. We have virtualized desktop solutions like Citrix. If you guys use Citrix for your classes, there's options to host things like that, and that small upfront capital expenditure and the capacity and capability that the cloud affords us is really a game changer. It's really incredible what you can do with these things. And so that essentially brings us to what we can offer you as a student who's trying to learn about this. There's a program with Amazon Web Services, since that's what we use. I'm kind of partial to it because that's what I work in all day, but these other providers have very similar programs that you can go through, called AWS Educate. And AWS Educate allows you, and there's a tutorial on Blackboard that you can click, and I think you guys get some extra credit for it. That you don't have to, there's no credit card required. You can sign up using your ASU ID and go through, and it takes you through something called Quick Labs, where you can go into the AWS console and you can create, you can create a web server, you can create you can look around and see what all you can do. You can host a website almost instantaneously. You can deploy it. You can build servers and delete them. And if you've never done anything like that before, it provides you the opportunity to play with that in essentially a risk-free environment, in that you're not going to spend money, you're not going to damage anything. You can create a server and completely butcher it, and it doesn't matter. It's a very sandbox. It's a wonderful sandbox environment that you can play around with, and it's free. So it does help us a great deal if you guys can sign up for that and do that. They help us with our classes, and I think there's some really cool tutorials you can go through. So thank you for listening to me ramble on here and dealing with my terrible illustrations. You'll see my website up, hosted on AWS very soon for these terrible illustrations. And so now, if you feel like it, go get that extra credit points. Go to Blackboard and do the AWS Educate sign up and build some cool stuff. If you ever have any questions or more interested in how we use AWS or the cloud in general, if you have questions about the cloud, questions about this, you can contact me. My ASU right is steve.schrock@asu.edu, and I'd be more than happy, to speak with you about the cloud or what we do, or some good training resources, or any questions that you might have. So thank you for your attention today, and we'll see you later.